What if you could undo your biggest regret? Not by learning from it, but by literally going back and stopping it from happening. The idea is intoxicating. It's the stuff of legends, from H.G. Wells to Hollywood. But what does science actually say? Can you time travel? The short, brutal answer is no. You cannot time travel in the conventional sense of going back to change the past or visit future events. But, and this is a huge but, the universe does permit several fascinating temporal phenomena that are frankly stranger than fiction. So let's unravel the real physics of time travel. Let's start with what is actually scientifically proven. Time travel to the future is real and measurable. It all comes from Einstein's theory of relativity, which tells us time isn't like a single clock ticking the same for everyone. It's a river, and that river can flow at different speeds depending on two things: how fast you're moving and how deep you are in a gravitational field. First, spatial relativity. Time slows down as you approach the speed of light. An astronaut traveling at 90% light speed would experience time passing much slower than people on Earth. For them, a few years might pass, but decades would fly by back home. This isn't just theory. GPS satellites demonstrate this effect daily. They travel so fast that their clocks lose about 7 microseconds per day due to velocity-based time dilation. Then there's general relativity. Gravity slows time. The stronger the gravity, the slower time passes. For our GPS satellites, this actually has the opposite effect. Because they're farther from Earth's gravity, their clocks gain about 45 microseconds per day. The net effect? Engineers have to pre-program the satellite's clocks to run 38 microseconds faster per day before launch, just to keep them synchronized with Earth. Without this correction, your GPS would be wrong by miles in minute, and you would be lost in somewhere forest while you were heading to a highway. This is real applied time travel. This has been confirmed with mind-blowing precision. In 2010, scientists at the National Institute of Standards and Technology measured time dilation between two clocks separated by only 33 centimeters in height. That's right, your head ages faster than your feet. Or consider muon decay. Muons are subatomic particles created in the upper atmosphere. They decay so quickly they should never reach the Earth's surface. But they do. Why? Because from our perspective, their incredible speed causes relativistic time dilation, stretching their lifespan just long enough to hit our detectors. They are time travelers from upper atmosphere. So going forward is easy, but what about the past? This is where physics gets weird. General relativity mathematically permits pathways to the past called closed time-like curves. These could form around insane cosmic objects like rotating clear black holes or through theoretical tunnels in space-time called wormholes. But this immediately leads to the mother of all problems, the grandfather paradox. If you go back and prevent your own birth by shooting your own grandfather, how could you have existed to go back in time? It's a logical contradiction that seems to break causality itself. So how do we solve it? Enter the Novikov self-consistency principle. It proposes a simple, brutal rule. You cannot change the past. Your actions were always part of history. Any attempt to create a paradox would fail. The gun would jab, you would trip, you would miss. The universe ensures self-consistency. Another solution is the multiverse theory. You don't change your own timeline. You simply jump to a new parallel universe. You might erase yourself from that timeline, but your original one remains untouched. The weirdest answer might come from the quantum world. A 2025 study by Dr. Lorenzo Gavassino suggests quantum mechanics might prevent paradoxes through thermodynamic constraints like a universe safety switch. Researchers have even simulated quantum time travel effects. Scientists at the University of Toronto observed negative time phenomena where photons appear to exit materials before entering them. This doesn't violate causality, but it shows that on a quantum level, time isn't as rigid as we think. But for now, classical time travel remains impossible. The energy requirements are astronomical. Wormholes require hypothetical exotic negative energy. And many physicists believe the universe has a built-in chronology protection mechanism, a law that prevents time machines to save causality. So where does that leave us? We're all time travelers. Every single moment you travel into the future at 1 second per second. We can change our rate of travel, fly fast, live near a black hole, and you'll jump further into the future than everyone else. The dream of a time machine is not about building a DeLorean. It's about understanding the fundamental fabric of the universe. It's about realizing that time is not separate from space, not a constant background, but a dynamic, malleable thing. We might never get to visit the dinosaurs or see the year 3000, but in our quest to figure out if we could, we have uncovered a reality far more spectacular and mysterious than any work of science fiction.